Welcome to the Deep Dive. We help you get informed fast. Today we're digging into something really fascinating. It's this blend of climate challenges and, well, some pretty cutting-edge innovation. We're focusing on Albany, New York. You might not expect it, but they're pioneering a really powerful energy solution, rain-powered solar.
Yeah, we're going to unpack the sources talking about their hybrid solar triboelectric systems. Sounds complex, but the idea is compelling.
It really is. And Albany, it's kind of the perfect spot for this. Its climate is unique. They get a decent number of sunny days, sure, about 184 on average, but they also get a lot of precipitation. We're talking 1,200 to 1,400 millimeters a year, plus plenty of overcast days.
So that mix makes it ideal, not just sunny, not just rainy.
Exactly. It makes it a fantastic real-world laboratory for this kind of tech. What we'll find in this deep dive is pretty surprising how they're using both sun and, crucially, rain for power. It's really about turning what seems like, bad weather into a genuine opportunity for energy resilience, making every drop count, basically. Okay, so let's get into the core of it. This innovation relies on something called triboelectric nanogenerators, or TNGs for short.
ENGs, that's right. The basic idea is generating electricity from friction. Simple concept, really sophisticated execution.
Friction from raindrops hitting a surface.
Precisely. Imagine capturing that tiny bit of static energy when a raindrop impacts a specially designed material. It completely reframes how you might think about a rainy day.
And the powerful part, as I understand it, is how these TNGs work with traditional solar panels.
Yes, that synergy is key. It's not one or the other. They complement each other. So you get continuous power generation, even during heavy storms or just those gray, dreary days when normal solar panel output, drops off significantly.
Right, so the grid gets a more consistent supply.
Exactly. Our sources show that during rainfall, these 10 enhanced systems can actually produce a significant amount of power. In some cases, during heavy rain, they might even outperform standard solar panels for that period. It's a potential game changer for reliability.
Wow. So it transforms those gray days from an energy downtime into an uptime.
That's a great way to put it. Yeah, it drastically improves energy resilience, especially in climates like Albany's, where the weather can be pretty unpredictable. But Albany isn't just keeping this in the lab. They're actively implementing it.
Like that community solar project, the Port of Albany 1.
Exactly, the Port of Albany Community Solar Farm, launched in 2024. It's already providing real energy bill savings for hundreds of local households. We're talking potentially thousands of dollars over the system's life.
That's tangible impact.
It is. And what's really insightful there isn't just the tech, cool as it is, it's the model. Albany's showing how you can have an equitable energy transition, making sure cutting-edge renewables actually lower costs for everyday people. Clean energy becomes a direct economic benefit, not just, an environmental ideal.
That's huge, seeing it deployed practically, saving people money.
Yeah.
And I read something about materials, too, like special coatings, even for homes.
Right. There's work on advanced materials like hydrophobic nanocoatings, super water repellent stuff. They help shed rain and, importantly in Albany, snow really quickly. This helps maintain efficiency even when it's dumping snow.
Makes sense. Keeping the surfaces active. So what's next? Where is this rain-powered idea heading?
Oh, it's definitely evolving fast. Researchers are pushing the boundaries, for instance, developing graphene composites. These look really promising for improving durability, making the systems last longer, especially in harsh weather cycles.
Graphene.
Okay.
Stronger, longer lasting.
And looking even further out, there are pilot projects for these really innovative hybrid grids. Imagine combining wind, rain, and solar.
All three. How does that work?
Well, they're integrating things like vertically mounted bifacial solar panels. They catch sun from both sides, which is clever. Then adding piezoelectric panels that actually generate power from wind vibrations like flutter. And of course, layering Tang mesh over surfaces for the rain capture.
Wow, a trifecta.
Yeah. And the idea is that this dramatically boosts energy capacity and efficiency, especially during big weather events like the nor'easters Albany gets. It leads to a much higher capacity factor, basically. They generate more power more consistently over time.
So, wrapping this up, what's the big takeaway for you, the listener?
Yeah.
Albany's approach seems multifaceted. It's the 10 tech for rain, yes, but also smart community programs making it accessible, and then this future-gazing stuff, better materials, hybrid grids. It really positions Albany as a potential model, especially for places with lots of rain or snow.
Absolutely. It shows we can potentially harness all kinds of weather, not just sunshine. It broadens the scope of renewables significantly.
Definitely moves beyond just solar.
Which leads to maybe a final thought for you to ponder. If every single raindrop, every snowflake, could actually become a source of power for our homes and communities, how might that change how we feel about so-called bad weather? Might change everything.